Hello physics enthusiasts. If you have clicked on this video, then you might already have an affinity towards the concept of physics and the mysteries of universe. I'm here going to help in making them easier for you to understand. To understand these videos, you don't necessarily need to have a prior knowledge of the concept being discussed. I will try to make it as simple even for a physics novice. This is Shobhatyagi from the Unwoggling Physics, and today we are going to uncover the mysterious world of black holes. We will know more about them and how they are formed. Can Earth actually get sucked into a black hole anytime soon, near in the future? How many of you already know about gravity? I guess all. So if you all know the Newton's law of gravitation and its equation, it looks something like this, where F is the amount of gravitational pull that the body experiences. G is a gravitational constant. M is the mass of the body on which we are calculating the gravitational pull. M2 is the mass of the body for which we are calculating the gravitational pull. And the R is the distance between the center of gravities between two bodies. Now imagine the chair that's placed in your room. It's exerting a gravitational force on you, and so you are. But the gravitational pull is weak enough in front of a giant pull of Earth, so it does not show much effect. Now consider two different planets with different densities, which means in the same volume they pack different amount of matter. For our system, we have two planets with density d1 and d2, where d2 is greater than d1. So based on the gravitational force that we are going to get using above equations, the gravitational pull or the force exerted on an object sitting on the surface of both planets will be larger in the case of the planet with higher density. Which means the higher the density of any object, higher the gravitational force it's gonna exert on anything at a similar distance. So to achieve the higher density, we need a system that can keep putting the matter into the planet. Well, this seems to be a hefty task for a human to do, but there are some space bodies that do it for themselves, and they are called the supermassive stars. Since these stars have higher gravity, thus they keep pulling everything that's come near them into themselves. Imagine the same setup of planet again, where d2 grows approximately close to unmeasurable value, or its gravity will become so strong that will start pulling its surface into itself. And the more it will decrease its volume, its density is gonna increase much further, and so does the gravity. Well, that's exactly what a black hole is. It's a place in universe where gravity is so strong that even photon particles, otherwise known as light particles, cannot escape it, and they falls directly into the black hole. The gravity is so strong here because the matter has been squeezed into a tiny place. This usually happens when a star is dying. Because no light can get out, people cannot see the black hole. They are invisible. Space telescope with special tools can find the black holes. The space tool can see how stars interact with the other objects or the light near them. Now the next big question, how big are the black holes? Well, black holes can be big or small. Scientists think the smallest black holes are just as small as one atom. And these black holes are very tiny but have a mass of large mountain. Mass is just amount of matter or stuff inside an object. Another kind of black hole is the stellar black hole. Its mass can be up to 20 times that of a sun. And there may be many stellar black holes in our own galaxy too. The largest kind of black holes are called supermassive black holes. These black holes have mass more than 1 million suns put together. Scientists have found proof that every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of our galaxy, that is Milky Way galaxy, is called the Sagittarius A. It has an equal mass that would be of 4 million suns and would fit inside a large ball that could hold only a few million Earth. So you can imagine the density over here. Now next big question is, how do black holes form? Well, a black hole is born when an object becomes unable to withstand the compression force of its own gravity. Scientists think the smallest black hole was formed when the universe began. The stellar black holes are made when the center of very big star falls upon itself or it collapses. When this happens, it causes a supernova. A supernova is an exploding star. Stellar mass black holes are born with a supernova explosion. They form when a very massive star, at least 25 times that of our sun, runs out of nuclear fuel. The stars then explode as a supernova. What remains is a black hole, usually only a few times heavier than our sun, since the explosion has blown out much of its stellar material away. Supermassive black holes were made at the same time as the galaxy they are in. We know less about the birth of supermassive black holes, which are much heavier than the stellar mass black holes and live in the center of galaxies. One possibility is that the supernova explosion of massive star in early universe formed these stellar mass black holes that over a billion of years grew supermassive. A single stellar mass black hole can grow rapidly by consuming nearby stars and gases, often in plentiful supply near the galaxy center. The black hole may also grow through mergers with other black holes and drift to the galactic center during collision with other galaxies. Astronomers are actively investigating these and other scenarios through observation and computer simulations. So the next question is, can a sun or Earth become the black hole? Well, many objects like Earth and Sun will never become the black hole. Their gravity is not sufficient enough to overpower the atomic and nuclear forces of their interiors, which resist compression. But in more massive objects, gravity ultimately wins. Gravity is the most mysterious force in the fundamental forces. It can be the weakest, but it can also be the strongest in the case of black holes. Hope this brought you a little closer to the black hole and their story. If you have watched the video till this point, then you might be one of those people who might be curious about universe and its working. So I appreciate your time you have invested in this video, and I will see you in the next video, in which I will covering the topics like neutron stars and Chandrasekhar limit, which is usually considered as the intermediate stage for the black hole formation. But till then, keep feeding your curiosity, and I'll see you in the next. Thanks for watching.